a mathematical topic tonight and a message. I always like a lot more math. So my mathematical topic is reciprocals of prime numbers, and my other message is about the value of real-world math and pure mathematics. So why do we like math problems that are posed in a real-world context? Well, they can motivate and engage students. They can give students a place to start where math makes sense. And the context sometimes provides a paradigm for their future work. So I want to compute 1/7. So I'm going to divide 7 into 1. And notice the remainders that I get as I go along. I get 3, 2, 6, 4. I get all of the numbers 1 through 7, except then when I get 1, it repeats. Notice though, notice the remainders that are 3 apart. 3 and 4 add to 7, 5 and 2 add to 7, 6 and 1 add to 7. Do you think that's a coincidence? That's just one little thing. So let's, I want to look at a table of reciprocals of prime numbers and the repeating decimal patterns. I didn't put 2 and 5 in there because those terminate. It looks like kind of a mess. If you look at the periods of these, that's how long it takes for them to repeat. You can see a few things. I've highlighted here. Some of them have period exactly 1 less than the number. Okay, as did 7. And the rest of them divide that number, divide 1 less than the number. So the period divides 1 less than the number. You might be wondering, how often does this happen? Well, actually, there's a conjecture on the subject that's been around for about 80 years. So with almost no work at all, we've reached a frontier of mathematics. Nobody knows how this works. We computed 1/7. I think it needs to start. And then one of the things I'd point out that means is look at what happens if you multiply that number by 7. You get a whole lot of 9s. That's not that surprising because really what we did was we divided 7 into 1,000,000 and got a remainder of 1, so it was 6 9s in a row. Okay. So but that says something interesting. 7 divides 999,999. 1/13 has period 6, so 13 is going to divide that. 1/17 has period 16 there, so it's going to divide that number. 1/19 has period 18, so there's some number we can multiply 19 by to get a string of 9s. Every number except 2 and 5, every prime number will divide a string of 9s. That's kind of weird. So for example, 43 divides 21 9s in a row. Every prime has one of those that works. Okay, so now I want you to look at this apparently meaningless string of digits there that has no rhyme or reason to it. It's at period 18. I'm highlighting the digits that are 9 apart, and look at their sum as I go through. Yeah, math is cool. Let me show you. So, let me show you another way to. I'll display that in another way. Okay. Does that always work? Let's try 1/7. We just had 1/7 up there. So at our fingertips, we've always had this thing about 1 over a prime number. 1/29 has got period 28. So you're wondering, does this work for all prime numbers? Well, no, it doesn't. Look, 1 over 31 has period 15. It can't. It's not even. If you got to build the universe to be as cool as possible, what would you really hope happens with a period of 15? 15 is divisible by 3. Wait a minute. 15 is also divisible by 5. So, for example, 1 over 29 has period 28. You could split it up 2 ways, 4 ways, 7 ways. Any way you do it, you're going to get a whole string of 9s. I recommend that you try it. There's a little twist in there that's very interesting. Here's a piece of wisdom I really love. When you want a young child to learn about cats, do you explain that a cat is a relatively small, primarily carnivorous mammal with retractable claws and distinctive sonic output, or do you arrange for the child to play with lots of kitties and let them form their own first impression? When you want a student to learn about that, do you give a great lecture? Or do you arrange for the students to play with lots of math kitties and let them form their own first impressions? I think the important thing is think it's important to not answer questions until your students ask them. I mean, does it make any sense to do otherwise? And then think about what you can do with pure mathematics, real world mathematics, whatever, to give your students experiences that will cause them to come up with those questions. Thank you.